Hey, welcome back. Good to see you again. Thanks for joining the channel. Today on the bench I have another Citation 24 high voltage, high current power amplifier. Now this is one of my eBay finds. I bought it this year, not too long ago actually, and I got a really good price on it. You guys are sleeping and these things are going out the door at a good price. But anyways, this one came to me via parcel, and this is what the previous owner wrote in his eBay ad. It says the bridge mono does not function and the right mono speaker does not work. Long story short, I accidentally broke off a peg in the right mono input, and I had to take the lid off, get it out, but in the process of the right mono must have been damaged. If you know how to fix these units, it's a one-part fix, but I'm not handy enough to try. But the other side works great. If you live in a small area with a single speaker, this is more than enough power for that. Well, we need two speakers running, not just one. I've priced it low enough for a fix-it person or someone needing a high-quality amp that needs some TLC. The masses will let me know. Well, I bought it. And let's look at it. The front is really nice shape. No damage that I can see. There's a very slight nick here. That might be just dirt. I'm not sure. It was kind of had a sticky film on it. And I did clean it, and it's better now, but it's not. It doesn't feel tacky. But yeah, it was something. So let's have a look inside. Actually, let's look at the damage first. Let me flip it around and we'll look at this damage that he's talking about. All right, here's the input. This is the right one on the bottom and the left on top, and they are cockeyed like they're not straight. This is all damaged. It's bent. But this switch is also damaged too, I think. I'm not sure. We'll have to open it up and have a look. So let me take the lid off and then we'll have a good look at it. Alright, so this should be loose. I've had the lid off before and had a peek inside. Come on, fight me. It's holding this. There we go. Underside of the lid looks great. It's clean. No heat stains, no smoke. And here it is. So like I said, I've had it open before and I just put the screws inside to keep them safe. So what do we got here? Back in this corner, this is all disconnected and loose. So, and things are bent. So he got quite aggressive and violent when he was trying to get this open. I don't know why he would do that, but I don't know. We're going to have to take this all apart. It looks like the switch is detached from the board and it's all mangled. So I might have to come up with a solution for a new switch and a solution for 2 RCA jacks. Okay, but the rest of this looks okay. It's a little dirty, but there is a problem here that I see right now, and you probably can't see it unless we zoom in. But this here, the output connectors are good. The fuses look all intact. I don't see any blown fuses. And everything else is okay. But I would not plug this in. I don't expect it would work, because I can see a big problem right now. Let me flip it over and we'll take the bottom off. Alright, remove the bottom. It's a really nice condition. This one is, well, it's dusty, of course. Needs a good clean. But it's not really seen a hard life, it looks like. But I see a big problem here. I don't know if you can see that as well. Oh boy. You see crack solders here. Have a look at this. Yeah, what you're looking at is a big crack across the bottom of the main board. Runs from approximately here down to here. So this whole board is broken in half pretty much. That's not a problem. We can repair that. These traces are cut though. A lot of these traces are cut. So plugging it in at this point would be probably fatal for the rest of it. So we're not going to do that. We're going to have to repair this first. It doesn't look like it looks like it took a hit maybe in shipping. Maybe the bottom, this block pressed on it, but I don't know. It's right here where these big filter cans are at, and there's a lot of weight there. So maybe one of these it took a hit, and the filter cans with the excess weight cracked the board. But yeah, this is easy stuff to fix. We can jumper all this. We can jumper all this out and make it work. A lot of these traces here are not even used. Some of these, like these empty transistor sockets here, these are for the Citation 22, because the Citation 22 has twice the amount of transistors on its output, and this is missing some circuitry. I think they use the same board for both amplifiers, so easy enough matter of just populating the board for whatever amp you're building for that day. So like this trace is not used, and it goes around to here as cut. This trace is not used, it goes to nowhere land. This trace is used. This one we can easily fix. This is a power supply point here, so that would be one of our rails. This is ground. Yeah, I believe this is ground here, and then this would be our high voltage rail. That's just a pad for mounting. These two are just pads for the capacitor, just a mounting pad. No current goes through those. This one's cut. This one's cut. This one's cut. A lot of these are cut. So we can fix that. It won't take as long. I might have to... I wouldn't mind trying to glue the board back together, but it's all like pushed out of position here. Like it really took a hit. I wonder if I could pop that back in. You see what I'm trying to do here? This popped apart, and this board is a lot higher than this part, and it's the edge is showing. What if I just pop that back in by pressing on it? There we go. See, I don't know if gluing it will do any good, but it's a weak board, right? So I might have to, I think I'm going to try gluing this board and see if I can get a little bit of strength out of it, because it's, you know, it's broken all the way from down here all the way up here. So let's see what we can do about that. So this is the initial problem. This is the output board here, and it's broken free from the screw. Well, maybe the screw is just loose. Let me take the screw out. Yeah, the screw is still holding. Now, but it's broken away from the switch, and that will kill both channels on this thing. So I'll have to deal with that as well. So my other plans for this, probably going to give it a full recap. This is going to be in my personal collection, so it's going to be fully recapped, repaired, and it's going to go side by side with my other Citation 24. And if I ever get around to it, I'll probably run these as monoblocks, since I have 2 of them now. And yeah, that'll be fun. So I get busy taking this thing apart. Really want to take that main board out so I can give it a good inspection and make sure there's no other cracks. This board has to come out. It's soldered to the other board, so that's coming out. And pretty much just going to have to disassemble everything here. The heat sinks and whatnot can stay if I can just desolder all the transistors and pull out the main board. And yeah, that should work. And then I can focus on repairing that crack, re-gluing it, reinforcing it. I want to reinforce it from the top if I can, in a few spots, so that it's not so weak. And then I'll jumper all the broken connections, and we'll use jumper wire for that. And then we'll do a recap, and we'll take it from there. So I guess I'll start by taking this board out and recapping it. Alright, so here it is removed from the chassis. Here's the input board. Actually, these input connectors are not that messed up that bad. I thought they would be a lot worse, but we just got cracked solders on all these connections that were part of the back panel. I mean, it's all loose now and busted apart. This switch here, this was like just together like this. This switch is pretty messed up. You can see here somebody tried something with this switch. So it's a 4-pole double throw, and the leaves in here are all missing. And yeah, these are all cracked, so this switch has to go. I'll have to figure out another solution for a switch. I can probably find a slide switch like this that I can mount on the back panel. I might have to jumper it onto the board, but if I'm lucky I'll get one that just fits right on there and solders in, but I don't know if I'll be that lucky. This part looks good. It's a little mangled. You can see the left side is mangled quite a bit. Maybe I can take that apart and straighten it just so it's functional. He said he got the center pin of his RCA stuck in one of these holes, and he tried to disassemble it to get it out, but made a huge mess of things. Okay, so I'm going to remove this from the rest of the amplifier, and I'm going to start recapping. I've had a lot of problems with these green TK caps in the past. I've seen some that have all failed, and I've seen some that have held up pretty good, so I'm just going to replace them regardless. This one looks like a low hours unit, so I don't think there's that much going on with as far as capacitors go. I don't expect to find many burned out ones or tired ones. All these transistors, oh, these are all cracked here. This row of transistors, these are all cracked. I'm surprised that channel worked. And this side too, this side's all cracked as well. So yeah, I'm surprised he said it worked. Looks like a real basket case, but we'll get it fixed. Alright, so yesterday I went through and did some searching for a new switch. This one here is mangled. Well, it's missing components too. It's missing the 4 slides. And couldn't find anything. I found some stuff that was close, but they were all, you know, the lever comes out the top, and none of these 90-degree ones. So I found another solution. I went through my old switch stash and I found another switch. This one looks like it's constructed the same by this is by Alps. Who made this one? This one's by Alps too. So these are both Alps switches. And what I'm going to do is, out of both of these switches, I'm going to create one good one. So this switch here, I don't know what it's out of. I don't really care, but it is the exact same dimensions, other than it's not a 90-degree. So I'll use the cap and the slide from this one. I'll have to take this apart and straighten, do some body work on it. It's pretty mangled. And then we'll use that cap on this switch assembly. And that will, actually they are identical in everything but color. So this will work out really well. And it'll be like an OEM switch that's just put back into service. And it'll be like a brand new one once I'm done cleaning it and reassembling it. Clean all these contacts. These ones are, look, this one's bent. Somebody really got violent with this, angry. So I'll get started on that, and I'll have to do some body work on this too. This is all bent up. So we'll do that. Now, I've been pulling out caps here. I pulled these caps out and tested them, and I really can't find a reason why I should change them, because they test like a brand new capacitor. And I'm gonna go through this board as well. I removed these 4, and I've been testing them, and they test out like new. So probably not going to do a recap on this thing unless I find some bad caps. I'll probably just spot change, but the rest of this will be left alone. The main thing on this board is all these cracked solders on these transistor assemblies. There's cracks, yeah, from thermal stressing, and this is really bad here. These are totally broken off. So I'll go through and resolder everything, clean it, pulling these caps out. I'm probably going to change some of these for audio grade. I think that's what they're trying to use here, is these 100 microfarad at 10 volts. These are the Matsushita ones, but they're known for leaking. And I don't see any leaks on any of these. Let me see here. Yeah, the blue Matsushitas, usually the purple ones leak the worst. These ones are blue. So if any caps are weak, they're going to get changed. The rest of them I'm going to leave alone, resolder the board, clean it, and then back in service. Alright, let's do this. So I took this apart here and I straightened it out a bit. It looks pretty a lot better than what it did. It's just this one side was all crinkled. Somebody doesn't have much patience when it came to disassembling their Citation 24. But we'll get it going, don't worry. Okay, so let's take this one apart. Okay. Got a blob of solder here. I'm going to get rid of it. Let's see here. I just don't want things springing all across the room here. There we go. Okay. So there's our switch innards. That's what we were missing. We're missing those 4 springs, and this one on this is damaged, so we're going to throw that away. We're going to use this. This is no good to me. So let's reconstruct this here. Let's take this apart and clean it. It's pretty black. Get some contact cleaner. 401B. Okay. You have to get some polish on this because it's not. Got rid of some of the oxides. Let's get a polish on there. That's quite a bit of polish. I don't need that much. There we go. That looks a lot better. Okay. All right. All right, here it is, looking pretty good. This is compared to the old one. See how it tarnished? The polish cleans it right up good. So I'm going to dump this in the ultrasonic for about 15 minutes, get rid of all the excess polish, and then I'll come back and we'll put it together. Okay, there it is. It's all clean now. Just going to get a little heat on it to dry it off. This is about 130 C. Ouch. That's good. Okay, everything's good there. I'll put these back on. Okay. Put a tiny amount on each set of contacts. Okay. All right. Now we need this part. Let's grease this up. This slides in here. Let's see. Okay. And then we have our little ball bearing is going to go back and forth here, so let's put a little grease here. A little bit on this side. Okay. Now, ball bearing spring goes first. Then the ball bearing. Then the housing. Okay. Oops. You know what? I got that upside down. Unbelievable. Perfect. Okay. Assemble this. Make sure they drop into, these drop into the slots. Otherwise they get crushed and then they're no good. And these are the only ones we have right now, so you gotta be careful with them. There we go. Okay. Crimp this down and we're done. Perfect. Yeah, that was a lot easier than what I expected, so that was good. Now I pulled all the capacitors off these two boards and tested them, and I replaced 6, I believe. There were 6 that were kind of weak, and so they got punted and they got replaced. Awesome. Okay. Now that's done. Now I'm looking at this thing and I'm thinking it's not that bad actually. The way the RCA jack fits in is pretty good. It doesn't get stuck or anything. I don't know why he had such problems. He probably had a bum plug. So I'm thinking of just reusing this. I was going to go with something like this. But I don't think it's necessary. This isn't busted and we can still use this. So I'm going to put this back on and we're going to go with it. Okay, that's done. This has been resoldered and cleaned, and everything's good here. This one's been, like I said, 1, 2, 3, 4, 5, 6 caps. The rest of them all tested fine, left them alone. Cleaned the back side of the board. I resoldered everything. Need to inspect it for bridges and then it can go back in. Then we're done. Alright, so it took me about 20 minutes, half hour to get that out. Pretty much all you do is you desolder all the transistors on both sides. Remove the 6 wires from the power transformer. Remove the 4 wires from the speaker output and 1 ground wire, and this cable comes off of the front panel. So it's pretty easy to take apart actually. It's not that bad. It's just a little bit of fussy. But look how dirty it is. I'm going to put this in the ultrasonic and I'm going to get this to sparkle because it just looks horrible. And plus I'll do a few other things. I got the this thing, for example. This is all dirty. Put that in there and a few others. Get that all cleaned up, and then we'll start working on that crack. Now these are testing fantastic. They're testing 6500 microfarad and about 17 milliohms of ESR. So kind of disappointing because I was looking for an excuse to change these and put it in 10,000s. But I think I'm just going to continue with them because they're working and they're in great shape. This appears to be a fairly low hours amplifier. There's no burn scorching marks on the board, or it's all good. Yeah. So we're going to put it together with the original caps because I don't see any reason to change these. These are 94 date code, so it's a 20-year-old cap. No, 30-year-old cap. Oh my God. So we'll put it all back. I'll do some ultrasonic. I'll probably do this board as well, even though it's not that dirty. Okay, now that I got the board cleaned, and I removed the circuit glue on these big capacitors. It reveals a little bit more damage than I first thought. We have a crack here, right along this this post here. This isn't. I don't think it's cut through the foil traces yet. It's right here, but I'm going to jumper this anyway, just to make sure that those foil traces are okay. Let's see. This crack goes right to this hole, and this crack goes right to this hole up here. This corner is cracked here. There's no traces, but it's just a mounting screw, and this corner is broken off. Let's see here. This corner is cracked a little bit, just starting to crack. That would have broke. So it must have taken quite a good hit to damage this board. But then I'm not pleased with this board, how flimsy it is. It is a. It would be better if it was a fiberglass board, then we wouldn't be talking about this right now. So how do I fix this? I can't really glue the crack because I can't open the crack up to stuff anything inside. Like, I can't get any epoxy in there. So that's just going to have to be the way it is. I'm going to jumper these thick traces with a probably I'll use a desoldering wick. That seems to be probably thick enough. Jumper that with that. But we need to strengthen this board because it is very flimsy. As you can see, it's flopping, and if it sees any more flopping and flexing, it's going to crack here. This crack already extends up, and this one will break easy. It'll snap right off. So there's not much holding this together right now, except a few wires. And so I'm going to strengthen this board by placing. I'll probably get some fiberglass pieces off of a printed circuit board, and we'll glue them right down to the surface here. Got a surface here where it's open and there's nothing in this way, so I can put down a patch here just to strengthen this. We got 2 big caps here. Where do these go? Here and here, I believe. But I might have about 1 centimeter between the two where I can put a strip as a patch, get about 1 centimeter wide by about 7 or 8 centimeters long, and glue it down to the board and anchor these 2 points together. And then I can probably fit a patch in here somewhere. There's room for one here. There, snapped in. And then I'll probably put a patch on the edge, this edge, and probably this edge, just to reinforce it and strengthen it. Alright, I think I'm at the point here where I can start gluing this board back together, because I wanted to do all the other work first before I did that. Yeah, first thing I wanted to do is I wanted to replace the caps, and replaced 1, 2, 3, 4, 5, 6 of those. 4 of these. These caps here. These are. Let's see if I can find one. These are these TK. They're 50 volt at 100 or 10 microfarad at 50 volt TK caps, and these measure down around 6 microfarad or so. They're really bad. 30 ohms ESR. That's what I was talking about earlier. These TK caps. Now it's only these 10 microfarads that are failed. All the other ones seem to be holding up. So it's all of the one specific type of cap, the 10 microfarad at 50 volts, that are failed. So I replaced them all. Funny thing is, in the service manual, they specify 10 microfarad at 16 volts, but in reality they're putting 50 volt caps in here. I don't understand. They must have had a surplus of them. But I got proper 16 volt 10 microfarad caps installed. I re-greased the power transistors on these 2 heat sinks, cleaned up the board and did the ultrasonic clean. Right here, these 2 caps were glued down with circuit glue that went conductive, and these 2 Zener diodes were starting to corrode. They weren't bad yet, but I got to it in time and cleaned all that stuff away from them. They'll be able to survive now without corrosion. Everything else that needs to be done is, well, the only thing that needs to be done now is resolder this board, because it is a mess with crack solders. I'm not pleased with the material they used to make this board. It's very cheap printed circuit board material. They could have upsized that or upgraded that. This is a, you know, it's a Citation amplifier. At least put some pride in it and don't put garbage components. Like, this board is just terrible. So what I want to do now is glue in my patches. I made a bunch of patches, and these are going to be for structural support of the board. There's going to be 5 of them. 1, 2, 3, 4, 5. Now, clean the board with alcohol. I cleaned my patches with alcohol, so now it's all time just to mix up some epoxy and glue them down, and then let it set. So let's do this now. Let's mix up a good amount too. That should be all right. I think there's really not many, but there's really not a better solution for gluing this back together. There's no way I could get glue inside the crack because I can't really open it up. So we're just going to do it this way. It should be good. I'm going to mix this up. I think this will hold well. It's not going to look pretty, but it's going to be better than what it was for sure. And then once it sets up, we can flip the board over and start stitching back together all the traces. Okay, that's good. So what I want to do here is I want to place these caps on. I'll place these caps in position because I want that center one to be at the right spot. So let's scoop this one up. Should be wearing gloves with this. Okay, let's let that spread. So this one goes down between these two. There we go. Okay. Now the reason I put the caps here is just to position it. So I want to be able to pull these caps out now. Why is it so difficult? Jesus. We're going to let this settle, and actually going to put some weight on it. Let's do the other ones. I'm going to put one here. Like this. And this is just security in case it wants to break further. Okay, and then there's one on the other side. This one goes up here. And then I got two small patches I'm putting under the emitter resistors. This one goes right here. I think this is a smaller one. Leave that one there. And then we'll see how this is going to hold up. That one goes here. Okay. I'm going to put some weight on these just until it sets up. Take about half an hour or so for it to set up, and then we'll okay. It's not going to look pretty, like I said. Alright, well, the adhesive's starting to set. Let's just start stitching this back together. I already did two traces here, these two, and I'm using solder braid, and I need to cut this one, so let's do this one together. So what I've done is I scrape back any of the solder mask here, just so that we have full contact. Cleaned it. And I'm going to cut a piece that's going to be about that long. About 1.25 inches. I'm using used solder braid so that I'm not wasting good new stuff. So let's just tack down one corner. Actually, let's put down some paste solder flux. Let's make this go a lot easier. Just tack down this one corner. Okay. So what I'm going to do is kind of flood this with solder. I'm going to use something to hold the braid down. Just going to flow it. Let it cool. Flood this side. And let's let this there, that's all there is to it. You want to dress it up, make it look nice. So I know it's tempting just to blob a blob of solder over the crack here, and it will bridge the joint, and it will make a connection. But I'll guarantee you it'll break in no time. You got to have something to back it up. So this is the copper braid I'm using is the strength of the connection, and the solder is going to be the glue kind of. So clean that up, everything's good. So we got a bunch of other ones to do. This one here, and then I got a few others. So I'm going to get busy. For the smaller traces, I'm going to use this stuff. This is wire wrap, silver plated wire wrap wire, and I'm going to use this on the back side and the front side, all throughout. So this would be adequate for these small traces here, like for example this one, connecting this base here. So there's 1, 2, 3. So yeah, I'll put a patch here, put a patch here, and then you know you get the message. I'll get it done. Have a look at this trace here. This comes from the collector of one of the output transistors. Okay, well actually it goes to the collector. This comes from the where does it go? Blah, 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 up here, right here. This is the positive supply rail, voltage rail for the power amplifier. So this is plus 50 some volts or 60 volts or whatever, I can't remember. And all the current for the amplifier flows through this trace down through these two jumpers. Okay. And then it goes from this side, goes this way to this jumper, to this collector of this transistor, which is fine. And then it also goes through this trace down through this vacant transistor spot here. This is empty, and then it continues on to the other collector of this transistor. Look at this trace here is cut on this side, and all the current is flowing through this one little piece here on this side here. And this isn't a problem if this is a Citation 22, because there will be transistors populated here, but on the Citation 24 there's no transistors. So all that current's going through that one side of that. So I'm going to put a jumper across here just to reduce its resistance. So I scraped it back, and going to solder a piece there. But this is the kind of stuff I'm looking at here, and you think they could have done something better for that. I don't know. I looked on the other side, and it's not quite the same. The other side's a little different. We have, okay, this one here is popular. This one I jumpered because the crack comes through here, and this is supplying this collector with voltage. So I jumpered this one right here because it's cracked up to here and it stops here. But if this cracks here, all it's holding was that one little side of that hole of the trace. So I strengthened that one. I think that's it. Finding little anomalies like that, you just gotta think them through and have a look at them and see how it works. But that crack goes right up here. I'm gonna have to fix this trace next. This whole pad is cracked here at this joint. This is broken here. This one I'm not worrying about because there's no electrical connection to anything. Same with this one, no electrical connection, don't worry about it. This one needs to be repaired. This one needs to be repaired. This one, this one, this one. You can't see it. This one, this one, this one, this one. This one's fixed. And so on. So yeah, so it's a little bit of how you doing. Alright, so there it is. All the repairs are done. And you can see the stitching I did. Added copper braid here, 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 and here, here. And those are on the current carrying traces, the thick traces. These traces here just go up to the front end, so it doesn't carry a lot of current, but they have them really low impedance lines. Another nice thing about doing this stitching like this is it really strengthens the board up. Like it really stops it from flexing at that spot. You can see now that I've got it stitched on top and then the bottom, it kind of It's one piece now. That's what you want. So I did a bit of a clean so you could have a look. See, I don't know if you want to see this. Focus. Some stitching over here. I used wire on the back side. I eliminated a few jumper wires. Where are we? Here we are. And then there's the center one. And then what my plan is, I cleaned the back off just so you can look at it. Now the plan is I'm going to route these wires, dress them up a little bit, and then I'm going to tack them down with some clear UV resin just to anchor them to the board. And the other side, I did a couple jumpers, 3 I think. So there's 3 jumpers there. Eliminated some other jumpers, added these ones. They don't look the greatest, but I should have kept it all on the bottom. It'd be invisible. Yeah, whatever. Looks a little bush league, doesn't it? Yeah, maybe I'll think about that. I might change it. If I can't dress these wires up, I'll change it. This one in particular, maybe I should redo that one. Alright, so I'm pretty much finished everything I want to do to this board electrically. I still have to anchor some of these wires down. It's coming along. I think the next step is I'm going to have to resolder this whole board. There's a lot of crack solders in these areas. I've been kind of fixing them up as I've been going along, but neglecting to look at all of them. So I have to go through and check every connection and resolder. I think I'll find a few more. But the crack is fixed right through here. This wire is waiting for a capacitor before it gets anchored. Yeah, so resolder this board and then give it a good clean, and then we'll move our attention onto the other. There's 2 or 3 other boards that need looking at, and I believe I'll be recapping them because if they have those TK caps, they're going to be needing changing. So that'll come up after this. So solder this up, and then we'll look at the other boards. Alright, we're at the finish line here pretty much, ready to start assembling. So we never did power this up. We don't know if it works or not, but I have an assumption that it does. From what the guy wrote in the eBay seller's description, it should be working. So let's test all of these to make sure we don't have any shorts. Well, we do have a short. Oh, that's a short there, yes. It's sitting on the other heatsink. But that's good. Kind of threw me there for a second. Check all the P&P ones first. Everything's good. Good, good, good. Everything's good. Perfect. Okay, let's check all the NPNs. Yeah, I didn't see anything roasted on the main board. If it's gonna short devices, it's gonna blow fuses and do all kinds of dramatic things. But I didn't see any of that, so everything seems to be okay. I think the main thing with this amp was cracked solders, and I think that's what ended up killing one of his channels. I don't know what he was doing. If he was playing around with the bridge mode switch in the back, and he effed it all up. But we fixed that pronto. We rebuilt the switch, and the other problem was the shipping damage. So that happened after the fact when he had it in his hands. So I have a feeling this was working fine. I think maybe one of the channels cut out because of the cracked solders, and that's when he started playing around with the switch and damaged it beyond his capability, and yeah, it's mine now. So let's get rid of some of this crap. This is that conductive glue, and it's all over those temperature sensors. I'll have to check them, make sure that they are not damaged by that. So let's clean this off. It's actually corroding the aluminum. Look at that. This stuff is nasty. Okay, so I think we're ready to assemble. I have everything back together. Here's the main board. All I need to do is solder back in the daughter board, and then we can, well, I'll put it back in the case first. I gotta clean this bottom first. I resoldered everything, and I still need to clean it. But that can go back in. These can go back in. Let me check. Are these loose? No, they're not. They're all tight. They're all tight. Yeah. I'll just torque them down again. The grease is okay. It hasn't dried up. So I'm just going to leave it alone. Alright. This little board here got all new caps because I started pulling them out and testing them, and I had a number of them that failed. Those TK caps, those green ones. So I just opted to replace them all because eventually all of the TK ones will fail. So that's done. And there's one cap down here that was failing, and that has been replaced as well. And then I replaced one cap on this little power supply board here. There's a 470 at 25 or 35 volts, I can't remember. That one was another green TK one, and that was replaced. Other than that, everything's good. Now don't forget there's a little board here on the back corner by these speaker operating mode switches. These switches set up your power transformer for either high voltage or low voltage, high current. And there's a little power supply here, and they call it a protection board or something. They call it a protection board, but it's actually just a little power supply. It's got a fusible resistor, a few caps, diodes, and it's just like a little power supply. From what I looked at the schematic, from what I can tell, is these transformers have a special winding. Well, they have the low voltage tap. Okay, you got your you have your low voltage tap, and then you have a higher voltage tap, and then depending on which way the switch is, takes power from whichever tap you're using. And this little power supply takes a voltage between those two taps and creates a little low voltage supply. It's about 11 volts, I think, 10 or 11 volts, and they use these little diodes and caps here to create this power. And then this power is fed to the front panel, and I think it powers the LEDs or something on the front. It tells you your indicator lamps and stuff. But the caps in here were bad. Here, I'll give you an example. This one I took out, it's 100 microfarad at 25 volts. It's a TK cap, it's a green one. There's two of these, and there was another 47 microfarad at 25. And all three of these caps were bad. Here's what it looks like on my tester. It's coming back at 29.9 microfarad. Has a 5 ohm ESR. This cap should have a ESR of about 300 milliohms or less. So that's definitely a bad cap. That's why I was saying about these TK caps at the beginning of the show, is these are problematic. These green TK caps, I pull them all out and replace them, even if they test good, which I've done in this amp. So there's not a green cap left in this amp. One of the last things to do is to reinstall these rubber blocks, these support blocks. And I'm just using double-sided sticky tape. And I'm just putting them back where they came from in the original positions. Provide a little bit of support for the board. Nothing, I suppose I could have glued them in, but I think double-sided tape will hold them for the next 20 or 30 years anyway. So there they are, reinstalled. Now we can put our bottom back on. Washed our bottom. It was quite a bit of dust on it, so we washed it again. And it goes on like so. Screw this down. Those blocks do make contact, so maybe it took a hit when shipping and smashed that board, but it's all fixed now. Alright, we're back together again. Let's do our first power up, and let's do our alignment, amplifier alignment procedures. So starting with this, let's try this first. Got 124 volts on my mains. Let's plug it in. And we have 19 watts drawn, and it came out of protect. Power is on. It's drawing 60 watts now. So even though I had the switch out, I think I had the switch out. No, I didn't, I guess. So there it is. On standby and power off, we have 900 milliwatts of standby power consumed, and then like I said, when we turn this on, we have protect light on, and then switches to the power button indicator. So we got 60 watts drawn. A little high, it's climbing up too, so we're going to check for DC offset on the outputs. Let's do that now. Don't smell anything cooking. 61 watts, keeps climbing up, so it's using some power. Let's see what we have for DC on the outputs. So first channel, we have 0. The other channel, 0 as well. Are we making a good connection here, or getting absolutely nothing? Let's try this again. Yeah, that's 0. Can't see that in the glare. Let's try the other channel. All right, 56 millivolts on the one channel. I think that's the right. And the left, we're getting 0. I think it's 0. Let me see here. Oh, you know what? I was checking ground. Okay. 57 millivolts, negative 57, and positive negative 55 millivolts. You can see that now. Okay. So everything's looking healthy so far. It just needs adjustment. Still around 61.5 watts, which is good. Nothing's running away on us. So let's let this idle for a while. Alright, VR1 and VR2 are on this daughter board here, and they're facing upright. So I'm going to connect the voltmeter to the speaker terminals. We're going to see if we can get this zeroed out. Get 50 millivolts there. A screwdriver happening. And what channel are we on here? Yeah, we're on the left. So let's see here. There we go. Yeah. That's what it needs. A little adjustment. Okay. .4. Let's leave it there and let it stabilize. We'll move to the other channel. Clean the pot a bit by working it. There we go. Well, fairly close. Okay, I'll let that stabilize as well. I'll come back and I'll check both measurements and tweak them so that they're close to zero as possible. So I've had this on for about 10 minutes or so. Noticing a lot of drifting here. It goes up to about 15, 16 millivolts and then goes back down to about 10 millivolts. And it goes back up and back down, so it seems to be fixated on around that. It's going to turn it down a little more. See if I can reduce this. We're still drawing about 61 watts on the outlet, and these heat sinks are starting to warm up. So I think our idling current's a little too high, so we're going to get this settled up first. If I can, let's give it a bump down. Try and get it floating around that zero mark. There's negative 9. And it's going up. And it goes back down again. Comes back up. Oh, we're going down. Okay, so I'm going to leave that around there. It seems to be floating around that zero mark. Let's do the other channel again. And what are we at here? 35. Wow, that really got out of hand. They do specify letting this warm up for 20 minutes before twiddling it. Yeah, so there's anything under, I think anything under 50 millivolts is going to be good. You're not going to hear it in your speakers if you 50 millivolt DC. It's certainly not going to heat your voice coil up, that's for sure. But you want to get it as low as possible. I think we're there now. It's going up. It's going down actually. It's negative. Is it going to come up a bit? No, still going down. I'm going to leave it at that. And then they specify, after we set it up to 0 volts DC on both channels, we set the speaker operating mode switch for both left and right channels to the 8 ohm position and allow 10 more minutes of idle, and then connect the voltmeter, which should be less than plus minus 60 millivolts. And we are just right at 62 watts consumption. So let's flip this up to 8 ohms. Do it with the power on. And the indicator light should switch here. Okay. And we allow this to sit for another. Power went up to 85 watts. That's not cool. Let's turn it back down. 63. 82. 83. Yeah, we really got a bad bias here. I think it needs to be turned down quite a bit. We're done with this though. We can disconnect this and move on to the next steps. Let me shut this off for now. Alright, so the idling current adjustment for the Citation 24 is kind of really confusing, to tell you the truth. This is what they tell you to do. Connect the 100 ohm resistance as shown in the figure and adjust R403 and R404 so that test point 1 to test point 2 voltage and test point 3 to test point 4 voltage add up to 32 millivolts plus or minus 3 millivolts. Okay, so what they want is they want us to measure test point 1 to 2 and have 32 millivolts between them, and test point 3 and 4 and have 32 millivolts between them. But what they're doing is they are measuring, here, let me show you. I'll show you on the schematic. Okay, here's a schematic of the output section of the power amplifier. Now we have 4 test points here, and they all have a 100 ohm resistor on them already. You can see R53, 61, R57, R65. They're all 100 ohms. And what they're doing is they're taking a measurement of, what are they doing here? This is drawn wrong. It is drawn wrong. That's a mistake. Let's go here. This one's drawn correctly. This one's drawn correctly. So what they're doing here is they're taking a measurement between this and this point, between this and this test point, and they're taking a measurement between this and this point using these 2 test points. So what they're doing is they have 2 sets of points for measuring idle current on these transistors. So this transistor might have a different idling current than this one. And what they want you to do is connect up resistors so that it averages out. If you connect 100 ohm resistors to here and then connect them together, you're effectively making these 200 ohm resistors. I don't know why they do it twice. But if you measure this here and it's 32 millivolts and this here is 32 millivolts, the average is going to be 32 millivolts. Get it? See what I'm getting at? So what we could do is we could measure this emitter resistor here, find out what the idling current is, measure this one here, and we can adjust it down or up to keep these both at around 32 millivolts. And we don't need to do the averaging thing. We can kind of average it out in our head just by taking measurements and knowing what they are. So 32 millivolts on a 0.27 ohm resistor times 2, I can do the math and we can figure out the current. Let me just hang on. So we should be getting about 60 milliamps of idling current through this. Yes, 60 milliamps times 111, 112, clear, 0.059 times 112 equals. So we should be getting about 6 watts of dissipation. We should be getting 6 watts of dissipation out of this chain here and this string here. So 12 watts for each channel. Idle power, 24 total. So let's go and measure some of these test points and see what we got for voltages. I think we're really too high, really, and we adjust it with the pots on the board. Okay, so for right now I have it on 8 ohm operating mode and I'm consuming 84 watts. And I'm going to connect my probes across the first emitter resistors, both of them, on the one channel. We're going to see what we get. It should be 32 millivolts or less. And what are we measuring here? Three millivolts. What's going on here? Why is my numbers jumping around so much? 10, 11, 12. Let's measure the other side. $64. Oh, okay. What do we have going here that it's so low on one side? Okay, we got. Let's turn this down. Why is it so touchy? Let's turn this one down. It is too high. Let's turn this one down to about 32. Okay. Now our consumption dropped to 68 watts. It's looking a lot better. Let's check the other side. .9, somewhere around there is pretty good. This probably won't heat up as fast as it was before. So I'll let that idle for like that for a while, and we'll come back and check it again. Let's do this side now, the other channel. Can't get in here. And we got 49. That's still high. Let's turn this one down. But first, let's check the other channel, the other side. Let's check this side here. 53. Okay. Let's turn this side down. Put it right at 30 for now. We'll let this idle. Power consumption drop to 57 watts now. That's more like it. And that's on the 8 ohm load, 8 ohm configuration. If I switch to 4 ohms, this even drops further. Now the manual's not clear on whether they want you to set it up in 8 ohm mode or 4 ohm mode. I would assume 8 ohm mode would be the one you set it up in because it has the higher voltages. And if it has the higher rail voltages, it's going to have the higher idling current. So I think that's what I would do, is do it on the 8 ohm mode and leave it at that. But if I switch this back down to 4 ohms, you see our power consumption drops to 43 watts, 44 watts. Can't see that glare. And turn it back on up to 8 ohm load. Goes up to 56. So we'll let this cook for a while, and it won't get as hot as it was before. And I think this is probably getting pretty close to being what I want. Alright, so I let this idle for about 10 minutes. I went back and checked the DC offset and tweaked it. It was down around 30 millivolts or so, so I put it back down to 0. These are not getting as hot as they were on the initial startup, which is good news. And this is our idling current on this emitter resistor. So let's pop it on the other side. It should be less than that. And then it's pretty stable at that 33 or 32 or whatever. Let's try this side. And that's good. Yeah, that's good. We're going to leave it alone. We're done. And let's check the other channel. Check the idling current on this side. If I can get in here. 31.29, that's perfect. It says plus or minus 3 millivolts, but you can always put it down on the low side. If you're interested in conserving energy, you can put it on the lower side. It shouldn't really affect your music at all. Let me see here. Okay, this side is 34, a little bit high, but that's okay. I'm going to leave it alone. It's good. Everything's tuned up and ready to go. We're consuming 60 watts in the 8 ohm load, and if I switch it to 4 ohms, it drops to about 46 watts. Alright, so we're all wired in for a power test. Let's turn this thing on and see what you can do. So here we go. I think I got my source on, scope's on, turning it on. Comes out of protect. There's no relay. It's a direct connection to the speakers. And we have our signal. So let's turn this thing up. Let's turn it up till we hit clipping. There's clipping. Just back it off. Right about there, I think. and we are at 30.61 volts RMS. Let's turn our timer on. Let's let this thing cook for a while. So right now we're consuming, what are we consuming? Right now we're consuming 409 watts. I'd say right there is peak, 31.32. 415 watts. That's probably the peak. So I'll let this go for a while. And we're at the 6-minute mark, and these heat sinks are just starting to warm up. They're not hot yet. I can put my hand on them, they're still cool. Just starting to warm up. On the other hand, my heat sink is really scorching. Okay, so we just passed the 10-minute mark, and everything's excellent, working great. It's starting to get hot, where I'm getting to the point where it's a little uncomfortable to put my hand on it. I can still touch it. It's not like it's that hot. But see, but it is proved this point, and let's turn this down. This, on the other hand, this heatsink is stinking up my room because there's all this hot smells coming off of it, and it is quite hot. Let that cool down. So I'm going to put a fan on the heatsink, let it cool down for a bit, just so I don't burn myself on it. And then let's do some square wave tests in a bit. So there's a 1000 hertz tone. Let's take this up to a frequency of 2 kilohertz, 3, 10 kilohertz. That is a sharp looking 10 kilohertz square wave. Let's go up to 20. And that is looking a lot better. A lot better than most ones I've seen. 20 kilohertz. Let's see what we can do here. Let's take it up. How far should we go? Right about here somewhere. Right there. How about that? That's 100 kilohertz. Very good square wave for 100 kilohertz. Most amplifiers by that time would be just a blob and a squiggle, but this thing's doing pretty good. Alright. Pleased with this amplifier. So let's shut it down and finish it up. Well, there it is, finished, put back together. It's working fine. Pleased with this one. A lot of work went into it. Came in from a eBay purchase, needing only a new switch, but it needed a lot more than that. It needed all these green caps changed out. Majority of these have failed. The larger ones, like the 330 microfarad and that, they test fine, but they will eventually fail, like the rest of these, because of age. A lot of the smaller ones failed first, and then as it ages, the bigger and bigger ones fail. Replaced a film cap, 10 nanofarad film cap. This is across the relay contacts for the power switch, because there is no power switch, it's all relay actuated. And this measured down around 9 nanofarads, which tells me it's down 10% from what it should be. These do fail over time because they get hit with high voltage arcs and stuff, and they break down internally, and then they slowly open up. So I put a new cap in, and that's fine. Yeah, this is done. So got another one. So I got a pair of these now, and I think run them in bridge mode. I think they're about 250 watts a channel, so there should be plenty noise for a block party, maybe. I don't know. So that's it for this one. Thanks for watching, and we'll see you on the next one. We got lots of stuff coming up. I know I've been kind of delaying what everybody's waiting for, the monster receiver, but I got some unexpected things come up. I have some warranty work to complete. I want to do that first before I start a new huge project. So I'll talk to you later, and take care, and see you next one. Thanks for watching.